We're going to go up on the upper level of this vestibule. I think this is 10 feet up on these. Let me check it for a second. Well, they're 9 feet tall to the top of the block, and then there's basically a 6-inch floor on it. So that's what we've got. It's a concrete floor that was poured up above. So we'll go on up on this. Okay, we're up where these boilers are at. I've got two of them. They're 350,000 BTU clean burn units. They can run together, but they'll run in sequence. We'll run the upper unit 40 hours, and then it automatically slips down to the lower unit. These things are good for about 20,000 hours before you rebuild them. I'm running right at 1,000 hours, 1,100 hours each on them per year. So I'm running someplace around 22 to 2,400 hours combined. They burn 2.5 gallons an hour. Last year I used about 5,300 gallons of waste oil, and we're heating 22,000 square feet with this system. So what you have on the back side here is a lot of plumbing, but what we're doing is we've got a heat supply and a heat return. The water comes out of this boiler at 165 degrees, goes out on this supply line, and that supply line goes all the way around the outside of the shop, and I'll show you that in a minute. There are 7 different areas that it drops down into. Be the shop itself, both sides, the service drive, the showroom is heated off this, and then parts department and the wash bays are heated off this same system. The only area in the dealership that's heated by natural gas is the customer waiting area and the office space. And it was just a matter, I couldn't plumb into that and make the thing work. But here's the key. This system last year cost me negative $67 to heat this building, the entire building. How that was is I sold 1,200 gallons extra of waste oil, 50 cents a gallon for $600, and that offset my natural gas bill, which was about $520 last year. And the majority of that was probably the decorative fireplace in the customer waiting area. Now, on the back side of this, what happens is the water comes in the supply side, returns from the different areas in the dealership at about 90 degrees, comes in the return, it goes through a mixing valve right here, so it mixes the 165 degree water with water that's being returned, because we want to get this water temperature up to about 125 when it goes into this side of the boiler. So it goes in this side, it goes through just a tube that's on the outside, comes out the other end at 165. I think the water flow on this thing is between 12 and 20 gallons a minute is flowing from one end to the other. It's all tied together. It's a pretty simple system. These 2 boxes here on the wall are basically mini computers. Now right now the only light that's on is for zone A3, and that happens to be the service drive. So the service drive is on now. As the different areas turn on, you can tell from the lights. It's about 40 degrees outside right now. We're running the service drive floor at about 78 degrees. We're running the room temperature at about 73. That's the only real part of the dealership that we didn't heavily insulate. Now right now, one of these boilers is going to turn on, and you'll be able to hear how loud it is. So that's all there is to it. So what it's done is it's called for heat in a certain area. In fact, it just called for heat out in the wash bay also. And so that's what's kicked on the boiler, because the hot water that's circulating isn't at 165 degrees. In fact, right now it's 132. And so that's all the water in the system is circulating at 132 degrees. So we'll walk back downstairs. This thing is, if you get into this system, I can give you a lot more information on it. I'm going to walk around the back side of it. You can see the two exhausts going up. We also, over in this area, this is a glycol tank. If you ever had a loss and a total freeze up on everything outside, extreme cold, you got glycol in the lines. I don't think you could ever possibly have that happen. Our floor was our floor, when we built the shop, we built it up in 1 foot increments of rock. Then we went about 12 inches of sand. Then we put a vapor barrier down, seamed the vapor barrier. Then we put 4 inches of insulation, so it's R20 underneath the concrete. Then we came up a little bit more with the sand, put in the rebar, and tied the tubes for the hydronic heat onto that. Then we poured the floor. The floor is 6 inches thick, so the hydronic tubes are sitting about 2 to 3 inches below the surface. And what happens is that floor is just a constant temperature. So using the glycol in there, it's never going to freeze up. This floor, once it gets warm, it just stays that way. The other thing up here is this controller, and this is the pump that's circulating the system. And that's all a balancing situation of how much water flow to maximize everything. So that pump runs all the time, and there's water circulating throughout this entire dealership unless the system is turned off. Now, we also up here have all of our fire apparatus. This is on this level. So we've utilized the space pretty well up in here. And as you can see, we've still got, we're 7 feet to the roof trusses going across, metal roof trusses. I said the roof was 22. I think it's 22 minus the trusses, which I believe are 5 foot, if I remember right. So I've got 17 or 18 clear span in here, 17 or 18 feet. As far as these units, I've had clean burn for about 25 years. This is the 3rd series of these that I've had. The thing about, if you're going to go waste oil, I would highly recommend clean burn, and the reason being, synthetics oils have a higher flash point, and the clean burn has a preheater on it, so it preheats the oil before it goes into the burner, and by doing that, the thing burns clean. These things will go about 500 to 600 hours before they start to get dirty and you need to clean them. So we clean them once during the season. It takes about an hour and a half on each unit. You basically turn them off, let them cool, pull the back, pull the front panel, get in there with a vacuum and a brush and vacuum out the soot. And what happens is, you can tell as they're starting to get dirty because your efficiencies go down. You get around it and you hear the thing running longer intervals, and you know the efficiency is not there. So anyway, 500 to 600 hours is what you get. We're running 1,100 hours a season, or about 53 to 5,400 gallons. Let's go on downstairs.